ASML, the titan of lithography machines, had shaken the semiconductor industry by officially relocating from the Netherlands. But what does this mean for the global chip market and ASML's future? Stay abreast of the latest developments as ASML bids farewell to its Dutch roots, venturing into uncharted territories. As the US tightens chip regulations, ASML confronts hurdles with advanced lithography systems, restricted from Chinese enterprises in the Netherlands, impacting its largest consumer market. This shift prompts ASML to consider relocating its headquarters, raising concerns about its departure from the Netherlands and the potential implications for its lithography machine business. While ASML remains silent on the matter, industry experts anticipate significant consequences given its dominant market presence. Despite these challenges, ASML's recent performance in 2023 signals resilience, with remarkable growth in net sales and profits, showcasing its adaptability amidst evolving regulatory landscapes and market dynamics. If ASML cannot uphold its previous advantage, it's reasonable for them to consider moving out of the Netherlands. Foreign reports indicate a shifting landscape, causing concern for the Netherlands this time. ASML's surprising decision to relocate its headquarters signifies a potential loss of talent, technology, and research outcomes. Recognizing the gravity of the situation, the Netherlands has made substantial investments, allocating nearly 20 billion yuan to ASML. These funds will primarily focus on improving infrastructure in the company's vicinity, including housing, transportation, and power grids. Despite recent developments, ASML has not provided a definitive response to the relocation, but has expressed concerns about future development. The decision to stay or leave is now less relevant, as ASML has opted to establish a factory in France to meet global demand for advanced chip manufacturing equipment, catering to Chinese enterprise clients as well. Should ASML persist in leaving, the title of the Netherlands as the hometown of a semiconductor equipment manufacturing giant may change hands. As a cornerstone of the Dutch economy, ASML's significance is undeniable. In essence, ASML's role is comparable to that of TSMC, with its impact extending locally and globally. While initially appearing strategic, aligning with the pace of regulatory restrictions, this move may ultimately undermine ASML's own interests, leading to a self-inflicted setback. Japanese Prime Minister Fumio Kishida personally inspected TSMC's Kumamoto plant, underscoring the government's commitment to stabilizing the chip supply chain. To support the Kumamoto plant's progress, the Japanese government plans to subsidize it with 732 billion yen. With the confirmation of a second factory, Wei Zheji's family expressed gratitude for Japan's support, emphasizing the plant's role in revitalizing the Japanese semiconductor industry. The launch of TSMC's first factory in Kumamoto is set for February, with construction of the second plant expected to commence this year and operations to start by 2027. These developments, totaling approximately 1.2 trillion yen, are poised to significantly increase local procurement rates over the next 6 years. Kishida highlighted the positive impact of TSMC's presence on various industries beyond semiconductors, including electric vehicles and electronics. Previously, Toyota President Akio Toyoda personally visited Wei's family, indicating the significance of Kumamoto Plant 2 in Toyota's efforts to reclaim control of electric vehicles and future vehicle technologies. Situated in the same seismic zone, TSMC's expertise in seismic design is underscored by the recent earthquake, highlighting its resilience in the supply chain. Reflecting on past experiences, including the 3 Elevents earthquake, Wei Zheji noted that TSMC's wafer fab equipment in Taiwan has largely been restored. The Kishida government's goal is to reclaim Japan's pivotal position in the semiconductor industry by heavily subsidizing TSMC's Kumamoto Plant 1 and Plant 2, with a total investment exceeding 1.2 trillion yen. Asahi Shimbun cited TSMC's statement, reporting that the company's 2 wafer fabs in Kumamoto are expected to generate 3,400 high-tech job opportunities, revitalizing the local semiconductor industry. In response to the chip shortage during the epidemic, Japan has recently allocated approximately 5 trillion yen. Having learned from this painful lesson, particularly its impact on industries such as automobiles, Japan is determined to reduce dependence on imported chips. With the rise of electric vehicles and the AI era, securing a stable supply of advanced chips is paramount. Despite Chairman Liu Dain's absence during Kishida's visit and external speculation regarding the impact of earthquakes, TSMC maintains close communication with its customers. During the recent earthquake, TSMC provided real-time updates, highlighting its pivotal role in the semiconductor industry. With TSMC's support, Japan aims to regain its former glory. As China's leading semiconductor foundry, SMIC represents the pinnacle of technological advancement in the domestic industry. Despite facing challenges such as technological limitations and embargoes on advanced lithography equipment, SMIC continues to pursue independent research and innovation. Under the guidance of experts like Liang Mongsong, SMIC has made strides in 14-nanometer wafer chip technology and is pushing towards more advanced chip processes. However, the recent removal of information about the 14-nanometer chip manufacturing process from SMIC's official website has left many puzzled. Despite its status as China's most advanced chip manufacturing process, there are questions surrounding the urgency to remove this technology from public view. Regarding SMIC's 14-nanometers process technology, the Shanghai authorities made a special announcement, revealing that SMIC achieved mass production 2 years ago. This technology was utilized in Huawei's Kirin 910 chip, demonstrating SMIC's capability at the world's advanced level. Industry insiders report that SMIC's 14-nanometers chips boast a manufacturing yield of over 95%, meeting over 80% of the chip demand on the market. While there's a notable gap between 14 nanometers and the current top 3 nanometers, the 14 nanometers technology adequately meets operational requirements in various applications, such as car chips and intelligent machine tool equipment, without the need for high running speed or lightweight properties. By opting for a 14 to 28 nanometer process, chip procurement costs are reduced, albeit with some space sacrifice, which is deemed acceptable given the continued demand for mature processed chips. Consequently, SMIC has shifted its focus to mature chip processes like the 28-nanometer process, as evidenced by the removal of 14 nanometers chip process introductions from its official website. Despite this shift, SMIC maintains its presence in Beijing, Shanghai, and Shenzhen, with 12-inch wafer chip factories catering to industries such as smart cars and the Internet of Things. Meanwhile, TSMC and other industry giants are ramping up production of 28-nanometer chips, reflecting a pragmatic choice for SMIC. As consumer electronics experience a downturn, the oversupply of high-end processed chips prompts manufacturers like TSMC to scale back production and prioritize mature process chips, like the 28-nanometer ones. This trend aligns with the growing demand in industries such as intelligent vehicles and AI, driving consumption in the market. Previously, industry behemoths like Samsung, Intel, and TSMC focused on high-end chip production, completing the transition to advanced process chips. However, amidst market upheavals, these manufacturers lack the time to pivot to mature processes like 28 nanometers, which requires at least a 2-year timeline to establish wafer factories. In contrast, SMIC in China boasts a clear advantage in production capacity. With the potential of all 4 newly built 12-inch wafer fabs, SMIC could increase monthly wafer production by 360,000 pieces, facilitating faster shipping and aiding customers in shortening chip profit cycles. Furthermore, while TSMC and Samsung bolster their chip production capacity, SMIC excels in quality, particularly with impressive yields at 28 nanometers. This quality advantage, coupled with competitive pricing, positions SMIC favorably, especially amidst rising outsourcing costs for TSMC and Samsung. SMIC's ability to maintain reasonable contract manufacturing costs and its focus on mature process chips, like the 28-nanometer process, further solidify its position in the market. SMIC not only possesses mature technological capabilities, but also has strategic investments in upstream and downstream supply chains, including crucial components like wafer lithography machines. By conquering challenges and offering domestically produced alternatives for the 28-nanometer process, SMIC is poised to achieve self-sufficiency and ensure stable output of 28-nanometer chips. Although SMIC's current focus on 28-nanometer chips may be a response to market demand, its commitment to advancing chip technology remains unwavering. Looking ahead, SMIC continues its pursuit of higher-end chips, with Dr. Liang Mongsong revealing the massing of core technology for 7-nanometer chip processes as early as 2020. With anticipation surrounding potential breakthroughs like Huawei's 9000 seconds chip architecture provided by ARM, SMIC's trajectory in the chip industry remains a compelling narrative to watch. What do you think this move signifies for the future of semiconductor technology and global trade? Feel free to share your thoughts and perspectives in the comments section below. Don't forget to become a part of the Revel Discovery community by hitting that subscribe button to stay informed about the latest technological advancements and innovations. Explore endless tech possibilities for an exciting future.